All right, let's keep on with our limits, but now we're going to be looking at continuity also. All right, so here's the definition for continuity at a point. Continuity at a point. Okay, so a function f is continuous at a if the limit as x approaches a of f of x is equal to f of a, period. Now, think about this for just 1 second, right? This is a no-duh situation. Yes, we have all this mathy stuff in there. Yeah, I get all of that. But think about what's going on. This limit means as I approach from the left and the right that I have an actual limit, right? As I'm approaching A. So here I am approaching A. So as I approach from the left and the right, I go to the same value. Then, if I'm looking at the value actually associated at A, means that whatever is going on is closed in there. So not only is my limit have value coming from the left and the right, but my function has that value. That is continuous. Right? Okay. So it's really, yes, we put all this mathy words to it, but it's actually a no-duh situation here because we already know what's happening. Oops, let me change my color. All right, so let's come up with a few criteria here for a checklist. A continuity checklist. All right, in order for f to be continuous at A, 3 criteria have to exist. In order for f to be continuous at A. ... Criteria number 1, f of A is defined. So there is an actual value at f of A. So it's there, all right? Criteria number 2, the limit as x approaches A of f of x exists, all right? So you have an actual value at A, the limit actually exists, and to make both of those things go together, they have to be equal. The limit as x approaches A of f of x has to equal f of A. And that is the kicker there. That's what makes it continuous. So yes, you can have that because, check at this. If you have this value at A, and you have a limit, right? So here is criteria 1 met. Here is criteria 2 met. Right? So that's why the third criteria is important, that the limit and the value of the function have to be equivalent before it is continuous, because this meets the first 2 criteria but does not meet the third, and that's the point of the third, right? So that one is not continuous. Okay, check this out. We want to look at discontinuity and points of discontinuity. So here's example 1. I'm going to scoot this over actually. Oops, because we want to see example 1 here. Oopsie daisy. All right, here's our graph of f of x. All right, we want to know criteria. I guess really we're just talking about this. I'm just going to throw some stuff out here and talk about it. I want to know discontinuity. There are a lot, right? So if I know that it's discontinuous at this end, it's discontinuous at this end, here, obviously right here at 3, and obviously right here at 5, right? And 7. Those are all discontinuous. A whole is discontinuity. Asymptotes, right? All of these, and I'm sure you guys are out there saying, thank you, Captain Obvious, right? No kidding. Oh, it's discontinuous. Yeah, there's nothing there. If you can draw without picking up your pencil, that is continuity. If you ever have to pick up your pencil to make these holes, then it's continuous between there, but not at these values. Obviously, at an asymptote, it's continuous up to that, but not at that asymptote, right? All of these things make an impact. Yes, there is a value. Look at 3. Yes, there is a value if I wanted to figure out if it's continuous at 3. There's a value there, so that's good. However, my limit from the right exists and my limit from the left exists, but my actual limit doesn't, so that beats out criteria 2. As soon as you lose a criteria, you don't have to go any farther. For a continuity checklist, as soon as you lose criteria, you don't go any farther, right? Just look at what's happening here at 2. Yes, there's a value. Yes, there is a limit from the left and right, but criteria 3 is what fails there because they're not equal, right? Okay. So continuity, looking at that checklist, what makes sense? That's what I want to know, right? That's what is happening there. Okay. Let's look at this one. Here's example 2. I want to determine whether these functions are continuous, justify using the checklist. Continuous, question mark. So here's A. F of x is equal to a 3x squared plus 2x plus 1 over x minus 1. Remember, as soon as one thing fails, then it all fails. So criteria number 1 is I have a value at f of a. Do I? Oops, I didn't even give you a, so that's not helpful, is it? When a is 1. What happens whenever I plug this 1 in? Exactly. So I've got 3 times 1 squared plus 2 times, 1. I'll just put them both in parentheses. Plus 1 over 1 minus 1. Fail. Right? As soon as the first criteria fails, then you're finished. If you make it through the first criteria, then you go on to the next ones. So automatic fail. So no, this is not continuous because it's undefined at 1, right? All right, let's try another one. What if I have this one? That's a B, contrary to what, oh, that's just making it worse. What if I have g of x is equal to 3x squared plus 2x plus 1 over x minus 1? I don't know why they changed the variable, but whatever. A is equal to 2. So far so good, right? Okay, let's do this thing. If I were to plug a 2 in here, g of 2, that's my first criteria, right? So I have 3 times 2 squared plus 2, oh, why do I keep doing that? Times 2 plus 1 over 2 minus 1. So what do we have here? 4 times 3 is 12 plus 4 plus 1 all over 1. So that's 17, right? 12 plus 5 is 17 over 1. So I do have a value. Check. Now let's check criteria number 2. Do I have a limit as x approaches 2 of my function? What is our first way to figure out if we have a limit? Plug it in. Always, always, always. Plug it in first. Always plug it in first. Lo and behold, because we literally just plugged it in above, we know my limit is going to be 17. All right. Okay. Now, I am asked for the third criteria to see if the value of my function is equal to my limit. And I meant to put an a in there because the value at a is that equal to f of x, or my limit. let me say it again. Is my limit as x approaches a equivalent to the value of my function at a? Yes, because we determined that from those first two parts. So this is yes. The function is continuous at 2. Good. If one worked, but another one didn't, right? Then that's how we pull that off. Okay, good.